Hey everyone, welcome back to the channel. In today's video, we are going to break down the execution process of a C program. And if you're curious about how your C program is transformed at every stage, you should watch this video fully. And whenever you write a C program, it is not immediately executable. The C compiler has to go through a series of steps to convert your C program into a machine readable form. And there are four main stages, and we will see them each of them in detail. So after we write our source code, the first stage it undergoes is pre-processing stage. So what will happen in the pre-processing stage? Let me give an analogy. Imagine you are preparing to cook a food using a recipe. The pre-processing stage is like preparation phase. Before you actually start cooking, you will be gathering the ingredients and will be preparing the ingredients. So pre-processing stage is like that. So let's see that via an example. So let me convert this file to hello.hi and I will show you how the code looks in the pre-processing stage. So for that we have a command gcc and then we have to mention -e, then we have to name the file name. Hello.c is my current file name, so I'm mentioning my hello.c, and also we can modify our output file name. Currently I'm not going to modify my output file name. I'm again just going to keep hello, but this time in order to create a pre-processed file we need to mention the extension as .i. So now my pre-processed file is created. Let me check. Yes, hello.i is created in my explorer tab folder, and let's see whether the particular stdio.h has been converted to the linked to the external file. So in the link in the first status file inclusion, so obviously it will swap the include stdio.h with the appropriate location of where this particular built-in function is present. So let's see whether it has done that. So it actually gave a lot of code here. We're just navigating it. Yes. So if you look here in the file inclusion, it added a path. So actually this is what in the pre-processing stage it does for file inclusion. The preprocessor technically gathers the code from the external files by adding a path in the hello.i. So during the pre-processing stage, it not only does file inclusion, but it also does many other activities like macro expansion, conditional compilation, and it will also try to clean our source code. For example, if we use any single line comment or multi-line comment, those comments will be removed during the pre-processing stage. So we can write comments will be cleared during pre-processing stage. So the during the pre-processing stage, it not only limited to file inclusion, but also it does all other activities. So let's see what is a macro expansion. To explain what is macro expansion, I'm just going to define a value using hash define by as 3.14, and also I'm going to write the logic for area of a circle. That logic also I'm going to define it in the hash define area of circle, and I'm going to get radius as a parameter here, and I'm going to write the logic. Pi r square is the area of a circle's logic, so I'm going to just write it pi into radius multiplied with radius. So this is the logic for area of a circle, and then I'm going to write, I'm not going to take input from user using scanf. I'm just going to hard code a radius value using float. Float is the data type, equal to 5.8 something, or I can keep 5.0. So I'm going to use macro to calculate the area. So float area equal to, instead of writing the logic again, I'm just going to write this particular constant value. Area of a circle is the name of it, and then I'm just going to pass this 5.0 into it. So this variable is passed here. So now if I just run the program, what will happen is the definition will be replaced with actual values. That's also done by preprocessor. If you see here, I defined pi as constant with a value of 3.14. So whenever the pi is used in this particular program, the preprocessor replaces the pi with actual value. The actual value is 3.14. And then this macro. The macro is used to calculate area of a circle. So the area of a circle is given ADS into this particular thing. So it is like a function, but preprocessor actually substitutes the formula in the code, and then we'll be getting the result, and the result is stored in the area. So to print what we just doing it, we can see that using printf. So the technically the reason why I'm telling is to understand what is a macro expansion and then how it is being done in the pre-processing. So now let's learn what is conditional compilation. To explain what is conditional compilation, first I'm just going to write a code and then I'm going to explain you. So I mentioned a variable named debug in the hash define. So I'm going to write a program to add two number. So this is the code for adding two number. And then we need to write a keyword syntax called if-def. I will explain you what it will do. So currently the debug is mentioned in the definition. So the preprocessor will include debug related code inside the if-def debug and the end-if block. So if-def and end-if, this is called as conditional compilation block. If the debug is defined, it prints the debug information. And if this particular debug is not defined, it will not print this particular debug information. It will only print the result. So let's see if this is working correctly or not. So I'm going to compile this particular program, gcc hello.c, and then I'm going to run now a.out. So you can see here the debug mode is also printed and then result is also printed. So now I'm going to comment this particular line number 2 to see what will happen now. So my assumption is this particular debug mode will not run. Even in the IDE, this particular line is not highlighted in the IDE. So let's see what will happen now. So sorry, I didn't save it. gcc hello.c a.out. Yeah, now it only produces the result as 30. So the summary is preprocessor handles all the commands that start with hash symbols like hash include and hash define. This stage prepares your code by expanding macros and including header files and handling any conditional compilation if that is present in your code. So the next thing is we will be seeing compilation stage. And during the compilation stage, the pre-processed code is converted into assembly language. The compiler translates the C code into machine-specific assembly instruction, and the output is basically in the .s syntax. And still, we can read the assembly code. It is a human-readable file. Now, the assembly code need to be converted into the object code. So the assembler converts this assembly code into object code, and object code is in the machine specific. It will be consisting the binary instruction. So the output is an object file. It will be mostly .o or .obj, which contains compiled function and data. But still, this particular object file is not executable file. To make the particular object file executable, it will undergo a stage called linking. In the linking stage, the linker combines multiple object files and links them with system libraries. The reason why it is doing this is because it will be mostly resolving the external references, because there used to be many function calls in the many different paths. So it will resolve all the external references and then it will produce an executable file, and the executable file mostly it will be depending on the target system, that is it will be it depends on the operating system. Either it will produce a .exe file or it will produce a .out file. After producing .exe and .out file, it cannot directly run on the particular platform. Here in this stage, loader comes into picture. So the loader, it will run as a user. We need to run the particular .exe or .out file. To run that, there's a command called ./ and then we have to give the file name .out or .exe depending on our operating system in the terminal. So once we give this, it will take the particular executable file and then load it in the RAM. The output can be seen in the terminal if it is a console based application. And after running this particular program in the terminal, even if there is any logical error, during that time we have to go and change the syntax, and again we need to start the compilation. So again it will undergo all these steps and then it will try to print the result in the terminal screen. If there is no logical error, then it will run the correct program in the terminal. So now I'm going to demonstrate execution process of C, that is execution process of each stage step by step by converting this file into .i.s. So let's see how to do that. So currently I'm just going to create a new file, that is hello world.c, and then I'm going to write a code. I'm just going to print hello world stdio.h and print hello world. So this is our code. So now currently if you see my tab, I only have hello world.c. So now I'm going to convert this hello world.c into the pre-processed stage. To do that, just open your terminal and then you have to give the following command: gcc -e and then write your file name. So here my file name is hello world, and then if you want you can change your output file name, but here I'm not going to change my output file name. I'm again going to keep my output file name as hello world only. So in the pre-processing stage, to see the pre-processed output, you need to mention .i extension here and then press enter. So if you see here, it is generated in pre-processed file hello world.i. If you go inside the pre-processed file, you can see all the paths, and then whatever include we are using here, it will be referring to that particular path in this file. So after pre-processed stage, the next stage is compilation. So now let's see how to do that compilation. To do that, you need to mention gcc -s. Again you have to give file name, but here instead of .c, you have to convert the pre-processed file into assembly file. So let's do that. You have to give hello world.i and then the output file, either you can give different name or else you can just give the same name, hello world.s. So you can see here the assembly file is created. So this is how an assembly code will be looking like. So technically we can read this assembly code. It is not that much difficult. It is also human readable only. So now we need to turn the assembly code into object code. So to do that, we just need to write gcc -c and just mention this hello world.s. And you have to mention the output file name. Again, here I'm not going to change my output file. I'm just going to keep the same hello world as my output file name, hello world. But here I need to give the extension as .o to create a object code. Now our object code has been created and we cannot see this object code until we have a proper extension. So the next, after creating object code, we need to link the object code appropriate to our environment. So currently I'm using macOS, so I think it will generate .out file. If you are using Windows, by default it will generate .exe. So let's see how to do that. So type gcc and then you have to enter this file name. Here we are not using any prefix, we are just writing hello world.o, and then we are going to write the output file as hello world.out. So now our out file is created. So now linker is linked using all the system libraries. Now we just need to load the program into RAM. To load the program into RAM, we need to run this following command, that is dot and slash. You just need to write hello world dot out. Hello world dot out. So now you can see here my printf statement, that is hello world, is perfectly printed in the terminal. So I hope you understood this stage by stage explanation. So if you like this video and if you found it useful, give a like for this video and share this video to your friends, and kindly subscribe this YouTube channel. We'll see you in next video. Thank you.
Part-time shadow cat, part-time. That is not a guy that I would ever want to try to battle rap.